Hello everyone, and welcome to this video in the series of StressOff. Today we are going to conduct finite element analysis of 1 cubic meter steel cube using Solidworks. To start, let's go to part, and then I would like to select MKS or even millimeter gram second system. Now when Solidworks loads, you will see this screen. What I want to conduct is a finite element analysis on cubic meter block. So let's start with a sketch. We'll create a sketch on the top plane, and we'll start by adding a square. Dimensions of this we'll just give using smart dimension. 1000 millimeters, and we'll add 1000 millimeters for the other edge as well. This concludes doing the sketch. So we'll come out of the sketching environment, and then we'll go to features and we'll do boss extrude. Now we want to extrude by 1000 millimeters, and then we'll just click on the tick. Now this has been done, so let's just go in and click on, and so we can see that the cube is ready for us. Now we don't need to create any face groups or anything like that in Solidworks, so we can just go straight to our simulation. So let's just add a new study. It is a static study, so we'll just click on OK. So a new study has been added. Now what we need to do is we need to first check the material. So let's go in and apply a material. Now here, elastic modulus that we see for this material, which is carbon steel, so 2.1, and if we want to, we can just change the Poisson's ratio from 0.28 to 0.3. But we can just keep everything as it is, and we can just say apply. I'll close this window. So when that has been done, we need to fix the bottom portion. So now let's go in and just click on the roller or slider support. We'll go on the bottom face, and we'll just say the bottom face has a roller or slider support. This is synonymous with fixing just dy equal to 0, and so x and z are left free to go. We just want to check if Solidworks lets us conduct this finite element analysis as we could do it with Calculix, Prepo Max, and also FreeCAD. So we'll add that, and next we are going to add pressure of 1 megapascal on the top face. It is 1 megapascal. After this, we'll just click on this green tick button. So the next thing that we need to do is create a mesh. We need to go to create mesh. In create mesh, we can just leave mesh density as it is, or we can go in and provide meshing parameters. We'll go with standard mesh, and the maximum element or the maximum size of the element is 100 millimeters, which is the global size, and the tolerance is plus or minus 5 millimeters. So let's just click on the OK button, and we can see mesh generated for us. Let's just count the number of breaks that one edge has. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this mesh is Similar to what we did for Salome Mecha, or we did for Repo Max, or even what we did for FreeCAD and Calculix. So after the mesh has been generated, the next thing that we need to do is we just run the study. Clicking on run the study, and the results are in front of us. The stresses that we can see all around are roughly in the range of 1 megapascals. Now the thing is, if we check displacement, we can see that the displacement is 12 millimeters, and that is because we haven't constrained the X and Z direction. Now what we can do is we can edit the definition, and we can just say we would like to see the displacement in Y direction. Click on OK. And here we can see a graph of how much is the displacement of the top face. If we check here, the displacement is minus 4.764 micrometers. So Solidworks does allow us to conduct finite element analysis even though we haven't stopped it from X and Z direction of the cube. Okay, so next part, we'll just go in and add some more roller sliders. So let's just go in and let's add more roller sliders, and we'll fix this face from going in Z direction, and we'll use the same thing, roller slider, for this direction so that it cannot go in X direction. Now after this, let's run this study again, and here we can see that the von Mises stresses are somewhere around 1 megapascals, and displacement specifically in Y direction, it's again minus 4.764 micrometers. So the displacement remains same. It's just that this body or this cube is now more restrained. Next, let's just go in and change the bottom face to a fixed face. So let's go in and delete these three. We can suppress them also. So let's just go in and delete them. And we can say we would like to have fixed geometry for the bottom face. After that, let's conduct this simulation again. And as we can see, the maximum von Mises stress is 1.718 megapascals, and also the displacement is minus 4.676 for the top face. Now, when we go back to the stresses, we can see that the high stress is at the edges, as is consistent, and these results are consistent with the other softwares that we have seen. The only thing is that the von Mises stresses are a bit on the higher side. The center part of the cube, it has stresses in the range of 0.5 megapascals, which again is in line with what was the stress for the cube in the other softwares that we have conducted. So that's it for this video in our series of StressOff, where we used Solidworks software. Next time we are going to use another software, and to find out more, just click on all of the links that are present in the video description below. Thank you and goodbye.